In one of my classes, I was given the assignment to create a project for something that I had no prior experience in, something that I was only allowed to use online resources for, such as YouTube videos, websites, and forums, and not allowed to use traditional resources like books and friends and family's help. So I decided to illuminate my daughter's tutu with LEDs, and I did this by coding Arduino. The best way to describe Arduino is actually defined by Arduino themselves. It's an open source electronics platform that's based on an easy-to-use hardware and software. It's intended for anyone making interactive projects. Arduino is a favorite platform among makers. There are many well-produced videos on the internet that show project examples and give great overviews of Arduino and what you can do with it. I will link to some of those in the description. When coding Arduino, it's important to consider what kind of board to use, as well as how to interact with the board using the code. Arduino IDE software. It can either be downloaded onto your computer or used online. Arduino has many different boards that are available. I decided to use the LilyPad Arduino USB and use that working with fibers. Ultimately, I did get to that point, but in the meantime, I ended up using the Arduino Uno in between. Arduino Uno is a popular board, and lots of example videos and project videos feature the Arduino Uno. The internet is full of resources on getting started with Arduino. Two resources in particular that were incredibly useful to me were Jeremy Blum's episode 1, Getting Started with Arduino. I Like to Make Stuff Maker 101 had a series of 5 videos on getting started with Arduino. I will link to both of those sets of resources in the description. I began first by downloading the Arduino software. Then I followed along with Jeremy Blum as he took me through the basic Blink project, which lets you see if your Arduino is working with your software by sending a signal using a sketch to cause the Arduino to blink for 1 second and then turn off for 1 second. Blink for 1 second, turn off for 1 second. After I did that, I decided to see if I could push it a little bit further by changing that from 1000 milliseconds or 1 second to 100 milliseconds, so 1/10 of a second, and it worked. After coding my LilyPad to blink on and off, I wanted to move on to creating output with the Arduino. I quickly realized that the videos I was finding all used the Arduino Uno as the platform for demonstrating, and with my non-existent understanding of how to use Arduino, instead of trying to use a LilyPad and translate that to Uno, I decided to just use an Uno so that I could more easily follow along with the video demonstrations. I also realized that they were using a breadboard for setting up the electronics, and without an understanding of how to use a breadboard, I had to find a resource for that as well. I linked to the breadboard demonstration in my description for the video. First, I followed along with Jeremy Blum's tutorial to cause 2 LEDs to blink on and off. Then I followed along with I Like to Make Stuff's videos to use a potentiometer to cause 1 LED to blink on and off at a different rate depending on how the potentiometer was turned up or down. Eventually, I was able to put all of that together and use a potentiometer with 2 LEDs. In this video, I demonstrated how I moved the power source for the red LED from being powered directly from the Arduino to getting its data from the same column on the breadboard as the white LED. And what I did not show is how the green and red and black cables all connect to the potentiometer and are able to control the rate of the blink on the breadboard using the potentiometer. Once I had gotten the Arduino Uno to create output with the potentiometer, I wanted to be able to code my LilyPad to produce a similar output. I had acquired some LEDs called NeoPixels, so I worked again using 2 sources between SparkFun's LilyPad Pixel Board Hookup Guide and Arduino's information on how to install a library. A library is basically a set of code that the sketch that you're working in can pull from so that you don't have to have as much code in a single sketch. At this point in my project, I ran into trouble that cost me about a 4-hour delay in time. When you work with a robot or a computer program, you run a compiler or something that verifies the program, and then you upload the program to your robot. I continued repeatedly to get a message saying that I was missing a particular file. I spent hours on various Arduino forums looking at different suggestions that maybe Arduino wouldn't work with the version of my Mac OS that I was running. I spent hours trying to get around this, and at one point thought that I wouldn't have a project to turn in at all. After hours of research, when I had almost considered giving up and starting over, I read a message that I had probably read multiple times, and it said, "Don't worry, it's not an issue to have this message. It will use the supplied default." I pondered what that meant, wondered how it could be not an issue that the uploader would have an error message, and then just tried it again, and it worked. Even though there had been an error message with the uploader, it worked. In my experience with robots, if it doesn't compile and upload, it doesn't run. But in this case, I learned something brand new. At this point in the project, I had a couple of decisions to make. I decided to daisy chain the LEDs together rather than to have each one originate at a different pin on the LilyPad. I also decided that instead of soldering or using conductive thread, that I would use electrical tape and wire in the interest of time.
This is my first attempt at daisy chaining these together. I am going to try turning power on to the Arduino and see what happens. Here we go. 1, 2 more to go after this. Okay, so I am currently working on daisy chaining these Arduino NeoPixels together, they're little LEDs. And at this point, when I turn on my LilyPad, both of them light up, and I'm going to add 2 more after this. Ideally, I would have done this with conductive thread or something like that, but I am short on time for sewing and soldering, so I'm just using this electrical wire and basically taping it so that it doesn't connect, so the different wires don't touch each other. And I am wrapping the black wire in white tape so that it will look nice underneath the Tutu. So I have this wire running to the negative, and then I'm going to add another wire to the negative to run off of that. So
My final step in this project was to actually use this LED light chain to illuminate this tutu. I borrowed a dressmaker's mannequin from a friend and was able to attach the chain of lights to the skirt. Again, I did this using tape instead of using thread or anything more permanent. When I have a little bit more time, I hope to go back and actually solder the joints and permanently attach the lights to the skirt, or permanently attach the lights to a different tutu. This project was a great deal of work, but I am so pleased at how it turned out, and I am so excited that I chose to do this project.